Lesson 4-3, multiplying and dividing rational expressions. In this lesson, we'll be able to find the product and the quotient of our rational expressions. The new vocabulary words would be rational expression and simplified form of a rational expression. So we've learned about rational functions. So let's talk about rational expressions and see how we could observe their forms and learn how to solve problems with it. So let's start with exploring reason. Consider the following graph of the function y equals x plus 2. What is the domain of this function? So all the possible x values we see are all real numbers here, right? No restriction. So all real numbers. And sketch a function that resembles the graph but restrict its domain to exclude 2. So we're going to sketch graph a function that is exactly the same, but we're going to restrict the domain to exclude 2. That means we're going to leave out 2. We're going to restrict 2. So 2 should not be part of the function. So in order to do that, how can we graph? Right? So we want to draw the same graph or anything that resembles this graph, right? But then we want to leave out 2. So how do we graph? Do we just graph until here 2 and then just graph? But how do we know this part is just 2 or if it includes 2.1 or 1.9, right? So in order to indicate that it's just 2, we're going to put an empty circle. Yeah. And so at 2, so that's 2.5, so maybe 2 is like over here. 2, we're going to put an empty circle here. Yeah, so it's the same thing with all real numbers for domain, but we're excluding 2. So consider the function you have sketched. What kind of function might have a graph like this? So can you think of any other graphs that would have similar domain? Well, maybe you have like quadratic function with an empty circle at 2, right? This could be 2. Or you could have rational functions, right? That may have an asymptote at 2, right? So there could be other domains, there could be other functions that have the same domain or very similar domain. So for example, we can think of an equation where if we're thinking about rational functions, right? We can have rational functions that have a denominator that equals to 0 when x is equal to 2, right? So think of an equation where the denominator equals 0 when x is equal to 2. So for example, in order to have 2 as a value that is equal to 0, how can we write a rational expression that have 2 as part of a 0, as a 0? It could be the only 0. It doesn't have to be the only 0. So for example, we can write so many different rational expressions that fit this domain. Maybe we could have other zeros that are excluded, the other domain that's excluded, so we could have other zeros. But for example, we can have a denominator that is x minus 2, which will have which will make the denominator equal to 0 and x is equal to 2. And then the numerator could be any other expressions. We could have x plus 2 or x minus 1, x plus 4. The numerator doesn't really matter actually. Yeah, so let me write an example here. So for example, you can have a function that has an x plus 2, say 2. Well, no. Yeah, 2 over x minus 2. Yeah, so this is just an example. So we're going to think about, throughout this lesson, let's think about how does understanding operations with fractions help us multiply and divide rational expressions. So we're going to see a lot of fractions, obviously, because rational numbers are fractions and rational expressions have fractions in it, and have expressions in the fraction. So let's think about the concept of rational expression. A rational expression is the quotient of two polynomials. So quotient is the solution for division, right? And then you need to have polynomials. So polynomial divided by polynomial is called a rational expression. The domain is all real numbers except those for which the denominator is equal to 0. So if you have a polynomial in the denominator, you will have some values that will make the polynomial equal to 0, right? So those are the values where the domain is restricted. So for example, we have x squared over x squared minus 9. And since the denominator cannot equal to 0, when x is equal to 3 or negative 3, the domain is restricted, so it's undefined. So the domain is all real numbers except 3 and negative 3. So the zeros of the polynomial is related to the domain of that rational expression as a whole. So polynomial divided by polynomial, this thing is a rational expression, and then all the values that make the denominator 0 would be restricted in the domain. Okay, good. So that's the basic understanding that we're going to build off of. Let's look at example 1. Write equivalent rational expressions. When are two rational expressions equivalent? So when they're equal to each other, we know they're equivalent rational expressions. So they could be simplified just like fractions could be simplified, right? These are all equivalent fractions, right? For rational numbers. So similarly, we can write polynomials into equivalent expressions like these. You can factor them out, and if the polynomial is equal to each other, then that's equivalent, right? So as long as your polynomials are equivalent for the whole rational expression, then they are equivalent rational expressions. Okay, so it can't just be partially equivalent. So if you have an equivalent expression in the numerator but different expression in the denominator, that's really a different expression. So it has to be equivalent for both polynomials. You can factor them, or you could simplify them. You could multiply them out in order to make equivalent rational expressions. Obviously, just write it in different forms, but they have to be equal to each other. Yeah, so this is an example of an expression that we're going to look at. We're going to look at expressions that are equivalent to this. We can factor out the polynomials and then find the domain of rational expression, which will have all real numbers except 0, 8, and negative 9, right? And then we can write other rational expressions that have the same domain. So yeah, if we look at this, And if we look at the last piece, they have the same domain. So they're going to be equivalent expressions. So just make sure that you have the same domain. And if not, they're not equivalent. So you have to look at it again. Maybe you made a mistake. And then you can, you can check if the ratios are the same. So x over x is 1, right? So check if you can make the ratio, you can compare the ratios to be the same. Yeah. So again, we're going backwards. The factored expression, if you multiply them out, or if you separate them and then make them equal to 1, and then you see x plus 3 over x plus 9, this is simplified expression, right? So is this the same? Is it still the same? It is still equivalent for all x except -9, 0, and 8, because this one, you only have a restriction for -9, right? But the original one have more restrictions because you have more factors. So the expressions wise, they are equivalent, but the domain may be different. So for rational expressions, you have to be careful with the domain because the restrictions are going to be eliminated when you simplify and cancel them out like this. Okay. Yeah, so let's look at try number 1. Write an expression equivalent to 3x to the 5th power minus 18x fourth minus 21x cubed over 2x to the 6th power minus 98x to the 4th power. Remember to give the domain of your expression. So do the same thing, write an equivalent expression. You can write a simplified expression, or you can factor them out and call it an equivalent expression. Either way, give the domain for your expression. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? All right, so if you factor them out, you can factor the greatest common factor for the numerator. You have 3x cubed, right? So factor out 3x cubed. And then you have x squared minus 6x minus 7. Yeah, minus 7. And then the numerator, and then you can factor this out further as well. X, and so this becomes 3x cubed times x minus 7 plus 1, right? Minus 7 and then x plus 1. All over, if you also factor this out, greatest common factor 2x to the 4th power, right? And so you have 49, right? So x to the 2nd power minus 49. 49. And then that means you have 2x to the 4th power times x minus 7 plus 7. So you have the same factors, right? So you can cancel this out, and then whatever is left is your expression. So we have 3x cubed. Oh, we can cancel out the x, right? So this one you can cancel them out except 1x here. So 3x plus 1 If you simplify the expression, you will have this. All over 2x times x plus 7. And then your domain is, it should be the same except the restriction, right? So the domain is for all x except 0, -7, and 7. So your original restriction stays, right? So all x except 0, -7, and 7 is your domain. So check your answers and see if you have factored it correctly and wrote the equivalent expression, and if you figured out the domain correctly. So if you figured out the expression correctly, you should have the domain right as well. Yeah, so that's 0, that's 7, and then that's -7, right? Yeah. All right, so let's continue with the next example in the next video.